Worlds so chemically active and so haphazard that they lurk in the shadows are the elusive worlds of the solar system. The most surprising thing about the solar system was, I think, how different it is. These moons are located around the solar system's moons. They were previously unknown or overlooked, but are now at the forefront of astronomical exploration. Surprisingly, they didn't all look like our moon. These so-called minor solar system members are of great interest. These moons are full of surprises. Science fiction writers have always found fertile ground in the solar system. With exponential advancements in telescopic technology, close encounters with unmanned probes, and new ballets of moons, the curtain is now lifted. Many of them are moving in one direction, but some are going the opposite way. They are passing each other, the inner ones, as they pass the outer ones. It was believed that the solar system contained 32 moons, but this belief was held for nearly 50 years. They were sized from Jupiter's moon Ganymede, which was larger than Mercury, to smaller asteroid-shaped ones such as Deimos and Phobos. This number has increased dramatically. In 2007, scientists announced the discovery of 20 new moons around Jupiter, 1 around Saturn, and 3 around Neptune. It was the CCD cameras that astronomical telescopes were able to use. These digital cameras are commonplace today. It is difficult for astronomers and others to agree on the exact number of moons in our solar system. More moons are revealed as cameras get more sensitive and telescopes become more powerful. There are 2 ways to classify the moons. Regular moons are those that orbit in a nearly circular orbit above the equators of their planets. Our moon was formed by an impact, but all regular moons co-emerged from the gaseous stew around their parent planets. This process is called accretion. Galilean moons are a classic example of regular lunars. This material is also going to make Jupiter, but it's a little more so that it accumulates into the moons. Moons with irregular orbits are those that have an extended orbit and are highly tilted toward their planet's equators. If their planet rotates clockwise, most moons orbit in retrograde orbits. Phoebe, a newly discovered moon orbiting Saturn, is an excellent example. Her celestial journey began as an independent traveler orbiting around the Sun before she was captured by Saturn. Regular or irregular moons must be within the gravitational reach of their parent planet. These orbits are known as the Hill sphere. This phenomenon was named after George William Hill, an American astronomer who lived in the middle of the 1800s. A Hill sphere, also known as the region around the planet where the gravity of that planet exceeds the gravity of the Sun, is described as the area. Within the Hill sphere, Phobos, Deimos, and Mars moons operate in very different ways. Deimos is pushed further out by the tidal forces that push the planet around faster than the Moon. Phobos is, however, rotating faster than Mars. Asaph Hall, an American astronomer, discovered these small moons in 1877. He named Phobos after the Greek god Fear and Deimos after his god Terror. Phobos is in a spiral of death. It orbits 3,700 miles closer to the Martian surface than any other moon in our solar system. It would be 20 times larger if our moon was as close to Earth as Phobos is to Mars. Its orbital period would not be measured in days, as it is now, but instead in hours. It would fill the sky at full moon. You know that the daily tides would rise and fall by tens to hundreds of feet each day, so the Earth's moon could eventually collide with the Earth in this situation. Secular acceleration is the cause of Phobos' predicament. A tidal bump on the Martian surface is created when Phobos races faster than Mars rotates. You can learn how Mars pulls Phobos closer toward its surface with every orbit. The dynamics of tether ball are very similar to Mars's struggle with Phobos. The ball is the moon, the pole is the planet, and the rope connecting the pole to the ball is the planet's gravitational pull. We see that gravity pulls the moon so that it accelerates. It moves faster and faster until it finally reaches the pole. This is exactly what Phobos is experiencing. Phobos travels faster around Mars than Mars rotates. The tidal interaction pulls Phobos closer together and speeds it up in its orbit. Learn more about Phobos' 50 million year expected pull-in so it can impact Mars and become a moon. Deimos, however, is moving slower than Mars's rotation. It's now unwinding the string the opposite way, and we can see that Deimos is moving further away from Mars. Deimos will eventually be pulled from Mars by gravity. Mars will eventually become completely moonless. Because Phobos' rotation is faster than Mars's, it appears that Phobos rises in the west and sets in the east. Instead of the planet rotating quickly under it, like our moon and other moons, and having it rise in the east and set west, it races ahead of its rotation. It rises on the western horizon, races ahead, and sets on the eastern horizon. Phobos will disappear in another one. It may be useful in the future for Mars colonization. Science fiction writer. Arthur Clarke wrote about this idea in his book, The Sands of Mars. Despite not being able to colonize Phobos, its proximity to Mars makes it an ideal way station. It's easier to travel to Phobos, which doesn't have gravity, than to battle the gravity of Mars to reach this surface. The enormous planets in the outer solar system, from Galileo to Stanley Kubrick, have captured our imaginations with their size. However, in real life, it is suicide to explore them. It would be almost impossible to function under the immense pressure of Jupiter's huge atmosphere. The moons of these giants could be a better platform for exploration or future colonization. These are the people who live on Jupiter's gravity-hostile planets and have little chance of supporting organic life. They might be a safe haven to future generations of planetary explorers. It was not until recently that much information was available about the moons belonging to the ice and gas giants. They remained mostly hidden from the gaze of their parent planets. Modern telescopes and unmanned space exploration have revealed a vast world inhabited by many moons, ranging from small, spherical planets to tiny ones measuring only 30 miles in size. Jupiter, the largest planet in the solar system, is a moon magnet. It began nearly 4.5 billion years ago as a huge gas cloud collapsing on itself. This is known as accretion, and it was the basis of the Jovian system. Although almost all of the gas and spinning materials went into creating Jupiter, a small portion clumped within Jupiter's orbit. These tiny accretions became Jupiter's regular moons Io Europa, Ganymede, and Callisto. Jupiter began to coalesce, adding its immense gravity to the many bits of the early solar system. When there was a lot of small flotsam or jetsam around the solar systems, giant planets were formed in a gas-rich environment. Depending on who counts, The number of Jupiter's moons can range from 60 to more than 200. It is clear that if you stood at the edge of Jupiter's atmosphere and looked up, you would see a spectacular dance of lunar objects. It would be cool to see the moons. You'd be surprised at how often you see them. You'd see Europa every second time you pass by. Every 4 times you pass by, Ganymede would appear. One member of the Jovian cast has been so battered by Jupiter's immense mass, it is literally bursting from within. In February 2007, the New Horizons spacecraft bound for Pluto focused its cameras on Io. It is about the same size as Earth's moon and orbits 263,000 miles above Jupiter's surface. The extraordinary volcanism that separates Io from other Jovian moons makes it stand out. New Horizons cameras took detailed photos of the glowing lava that was scattered on Io's surface. Above the surface of the molten moon, a huge dust plume 200 miles high rose. Io, just like all Jupiter's regular moons, is named after a Roman mythological lover of Jupiter. Galileo discovered it in 1610. It was first photographed by Pioneer L in 1974, and then again by Voyager L in 1979. For decades, scientists have been puzzled by pulsating activity. Io is approximately 1 ton per second of material each day. It is a remarkable machine. Io is too small for a molten core to have been maintained since its formation. It is likely that another mysterious process is responsible for the heating. The entire interior of Io may be molten due to the fact that it orbits around Jupiter. This is called tidal heating. The immense gravity of Jupiter causes friction in the core of Io. Jupiter creates its own masterpieces just like a sculptor who needs clay lumps. A little bit of tidal heating can make a moon malleable. It can be stretched like clay or deformed by gravity from the parent planet. The moon's surface is very cold. It breaks like pulling clay apart quickly. It'll break. The interior, however, can flow and stretch as it is heated and kneaded under the gravity of its parent planet. The orbits of most regular moons are circular. Tidal heating requires that the moon be placed in an oblong orbit so that the distance to the host planet does not change dramatically during one revolution. These eccentric orbits can only be created if the gravity of another moon is disrupted. A moon in an eccentric orbit is one that moves closer to its parent planet than a round orbit. It gets squeezed when it does. It is more difficult to pull apart when it is closer. Io is orbitally in resonance with the companion moons Europa and Ganymede. Jupiter and Io are trying to establish a synchronistic relationship, but Europa and Ganymede pull Io in opposing directions. Jupiter's back is stretched out and squeezed by the act. A second reside effect of the tidal heating at Io that is responsible for its impressive volcanoes. It is the most visible stationary object in the solar system, a massive gas cloud. Professor Michael Mendillo of Boston University discovered a large cloud of gas that stretched a great distance from one side to the other. They were the first to photograph the whole nebula and discovered its origins and the mechanism that keeps them growing. It is also small, so it doesn't have much atmosphere. These volcanoes continue to provide the material for an atmosphere. You might wonder, well, it doesn't have a tremendous atmosphere if all those volcanoes are still going on for eons. It's because of the material escapes. The main gas is sodium. It is only 5% of Io's ejected material, but it can be easily detected by telescopes on Earth. The orange glow of sodium is due to its chemical properties. In fact, sodium is used in street light illumination in many cities around the globe. The sun's light and electrons from Jupiter's magnetic field pelt the sodium and other gas molecules. Some of these particles are ionized with protons and electrons. These ions, now in plasma form, are taken on a ride with Jupiter's powerful magnetosphere. Because it has been captured by the magnetic field, its speed is dramatically increased. It's almost like they are on a cosmic carousel. Here, the poles are represented by the magnetic field lines. Every now and again, a sodium atom is picked up with the electron. Now, I am in the Jupiter plasma chorus, along with all other ions, electrons, and ions recombined. The magnetic field does not limit the neutral, and it travels at a faster speed, enough to escape Jupiter. They form the largest visible cloud ever seen in the solar system. The nebula would look the same size as 12 night skies if we could see it with our naked eyes. It is so large that Mendillo, along with his team, created their own telescope to see it. As it turns out, a small lens, such as a pair of binoculars, is all that's needed to see a large field of vision. Although the telescope might have appeared ordinary in 1991, its camera was extremely sophisticated and revolutionary in comparison to digital cameras at the time. Once you have a picture in numbers, you can do a lot of things with it. Mendillo and his colleagues knew sodium existed in the nebula. The Earth's atmosphere also contains sodium. They were able to compare digital photos of Jupiter's and Earth's atmospheres to create an image of the nebula. It was difficult to do this if you only had 2 photos and a piece of paper. The digital camera has revolutionized how images can be processed. Although Lo could be an amazing scientific and aesthetic destination, its hostile environment likely prevents it. It would be hard to land an unmanned probe among Io's convulsing fissures. Jupiter orbits another moon, which could support human exploration and possibly even support alien life forms. Europa is one of the most intriguing and mysterious objects in our solar system. It is unlike any other place in the solar system, and even more so than anything else on Earth. There are cracks in the ground, it's mottled and chaotic terrain, and it looks almost like icebergs. Europa is an alien moon, as we know. Could it also be home to other life forms? Europa orbits Jupiter at 400,000 miles, about twice the distance of Lo. It is also molded by gravitational waves, just like its convulsive counterpart. Jupiter is the most powerful. Its mass pulls the reluctant moon towards its surface, much like a lover. Europa resists its gravity, and the two form a type of symbiosis that extends hundreds of thousands of kilometers above the gas giant. It's more than Jupiter pulling at Europa. Europa is pulled in different directions by Ganymede, a smaller cousin. It is the same orbital resonance that has such dramatic effects on Lo. Europa is, however, a very different story. Europa's surface has temperatures of -550 Fahrenheit at certain places, but there is heating. The moon is also a magnet for water, which rises to the surface of Europa. This water is actually glacial ice, and it rises from the underground ocean. It oozes onto the surface, repaving it like a Zamboni makes an ice rink. Europa's ocean is believed to be only a few miles or less below the surface. Water was the foundation of all life. Could it be the same on Europa and other moons? The universe could have the most common habitat, with icy satellite oceans. Although Earth may be rare, Icy satellites are likely to be plentiful. The New Horizons spacecraft, which was on its way toward Pluto and other outer reaches of our solar system, flew close enough to Europa in February 2007 to take some amazing pictures. Crop circles are geological patterns visible only when the sun rises or sets behind Europa. They are extremely large. You could, drive around one of the circles that you see. Then, slowly go in, travel to a place that is a few hundred feet below the surface from which you came, then climb back up. When you take into account their size, the resemblance between Europa's crop circles and the mysterious ones found in the countryside on Earth is negligible. Each is approximately 20 million, 3,000 miles in diameter. They are too small and uniform to be considered impact craters. Comets and asteroids come in many sizes and shapes. Europa's crop circles look remarkably similar geologically. Even though nothing has been proved, it appears that the great mass Jupiter could once again be responsible. It is believed that Europa's icy cover is not tied to the core moon. It's actually floating above the ocean as a spherical glacier. Jupiter may have shaped the polar region and, over many thousands of years, slowly pulled it toward the equator. This creates a line of small depressions that drops from the polar area to the equator. Europa's ice crust would have a structure similar to Earth's icebergs, and most of it would be below the ocean's surface. This has enormous implications for future exploration. This means that there must be 8 to 9 times as much ice beneath them in order to allow this kind of large-scale topography. The iceberg theory puts to rest the idea that Europa's subsurface ocean could be tapped easily through a thin crust. Before a Europa lander can reach the surface, it will need to have ultraviolet data and radar mapping. Future explorers will need to look for hot spots where the mysterious ocean has risen through the surface, and then try to find a way into it. These explorers might instead choose to establish a base on Ganymede, Jupiter's largest moon. While Phobos may be used by Ganymede to explore Mars, Ganymede could do the same with the Jovian system. It is larger than Mercury, and its gravity is stronger than any of Jupiter's moons. Its orbital residence is with Europa and Io, but it's far enough from Jupiter to be less affected by the gas giant's constant tides. You could also park in a large crater at Ganymede and create a domed protected area that is protected from the Jovian charged particles. This would make it a safe place to study Ganymede and its magnetic field, its interior, and the entire Jupiter system. Ganymede, the only moon in the solar system that has its own magnetic field, is Ganymede. Ganymede must possess sufficient mass and a hot core to be able to claim this distinction. Its mass is apparent, but it is not clear where the heat is coming. Both Io and Europa's tides affect Ganymede. However, the orbit measurements show that it is round enough to avoid the stretching and squashing that Jupiter's smaller cousins experience. It is possible that Ganymede experienced a change in its orbit, which could have caused it to spin slightly. Or maybe Ganymede's eccentricity went haywire and generated heat inside Ganymede, which would have made the core very hot. We don't know. We do know that New Horizons' recent flyby over the Jovian system provided us with a glimpse of the amazing wonders we can expect on Jupiter's other moons. Scientists are excited for the day when a lander lands on one of these moons and begins to unravel the mysteries of these worlds. Saturn is orbited by another icy moon. Although it is too small to retain its own atmosphere, that doesn't prevent it from taking over the atmosphere on its parent planet. Even though Enceladus is small, it's named after a Greek tribe of giants. Europa Enceladus orbits Saturn in an eccentric orbit, just like Io. Saturn's tidal force heats the Moon by kneading it. It doesn't regurgitate the molten material, but it does coalesce into a huge gas cloud. Water doesn't rise to the surface as it does on icy Europa. Enceladus actually spews plumes of icy liquid into Saturn's atmosphere. It is not a volcano, therefore. It is more like a geyser. The water vapor can then orbit around the tiny Moon, or Saturn's gravity pulls it towards the planet. Their work on the torus for Lo Michael Mendillo was interesting, and so his team at Boston University started to look into Enceladus effects on Saturn's atmosphere. It turns out water is a great catalyst for electrons and ions to recombine. Scientists relied on computer models before Cassini to predict the atmospheric conditions around Saturn. They suggested that Saturn should have an extremely robust ionosphere. Surprisingly, Cassini's data showed that Saturn's ionosphere was only 10% of what computer models predicted. It appears that Enceladus' icy water is neutralizing charged particles in Saturn's ionosphere. Scientists discovered by chance the effects water has on Earth's atmosphere. In 1973, NASA launched Skylab's Skylab workshop. It launched the last Saturn V rocket, the Moon rocket. It had never been launched in a way that allowed it to burn as much as the ionosphere. This gigantic engine dumped water vapor at a rate of 1 t per second from a huge rocket motor into the atmosphere. The ionosphere almost vanished that day. The LT caused a large hole in Earth's top layer, the ionosphere. This hole allowed the sun's radiation to penetrate the atmosphere. However, the long-term effects of this event have been substantial on Saturn. Enceladus continually dumps 6 tons of water into its atmosphere every minute. Although Enceladus is not expected to completely destroy its parent planet's atmosphere, scientists are concerned about this tiny moon of 300 miles. Saturn has also been paying attention to it. As we work to prepare probes for Europa and Phobos and analyze data from Enceladus, a whole new set of moons appears. Prior to the 1990s, most astronomers believed that there were only 34 moons in the solar system. Many of these were regular moons, just like our own spherical body that orbit in the same way as its host planet. However, only a few of these satellites were known as irregular moons. These moons are unusual because they follow long orbits. Their orbits are tilted, and they rotate in opposite directions to their host planets. They look like flying potatoes, splinters, or misshapen lumps. Because they are small and often very dark, it has been difficult to find them before. Within a decade, the lunar landscape was transformed by digital photography and light-sensitive optics. Dr. Brett Gladman, University of British Columbia, discovered his first irregular lunar sighting in 1997 at Palomar Observatory. Since then, Dr. Gladman has revealed the solar system. You can detect objects in outer solar systems by watching them move relative to background stars or galaxies that are stationary. If you take a photo of the sky, wait for an hour, and then take another one of it again, none of the stars will have moved. However, distant objects in outer space will move by a visible amount. You can compare the two images to see a moving target, just like we have here. It could be an asteroid, a comet, or an asteroid. Or, if it orbits in a retrograde fashion, a new irregular lunar. The important distinction between regular and irregular moons is captured. They formed independently from their host planets and are most likely part of the debris that formed our solar system. A classic example is Phoebe, Saturn's largest irregular moon. Saturn orbits Phoebe very far away. It orbits in a very inclined and elliptical manner. It orbits in retrograde. Voyager images indicated that this object could be an asteroid, and so it was thought it might be a captured asteroid. We now know that Cassini's body is very water-rich. This pretty much eliminates the asteroid belt. Phoebe could have possibly come from the Kuiper belt, which is in the outer reaches of the solar system. Kuiper belt is believed to be leftover material from the formation of the solar system. It revolves about the Sun, beyond Pluto's orbit. Another theory, however, suggests something entirely different. It is more likely that Phoebe formed in a separate orbit around the Sun, and was then captured into orbit around Saturn. Most of the objects formed close to Saturn's orbit were either accreted or ejected by the solar system. Phoebe would then have been made from the planetary debris floating around Saturn at its birth. It could be made of different material from some of the other irregular moons orbiting Jupiter. Astrogeologists might be able to identify and compare the various ingredients that created these gas giants if this is true. There are three main theories about how Phoebe and other irregulars lost their independence. Two of the irregulars could have been captured while the solar system was still in formation and the planets were still accreting gas and debris. The most simple theory of gas drag is the gas drag theory. When a comet or an asteroid passed through the gaseous mixture, thick gases swirled around the accreting world. We know that the satellite systems of the giant planets were built in an accretion disk around each of them, sort of like a miniature solar system. The gas and dust in the disk could also be used in its outer regions to create friction, where passing planetesimals are slowed down and then captured into orbit. The second theory is actually a variation of the first. Sometimes it's called the pull-down theory. Instead of being caught simply by passing through the accreting gases, an object is instead drawn into the orbit of the planet by its growing gravitational force. Both the gas drag theory of capture and the pull-down theory of capture works well with Saturn and Jupiter because their combination of ingredients was large enough to slow these passing objects. What about Neptune, Uranus, and other icy giants? Due to the extreme cold, they formed slower, and it's hard to believe that their icy mixture of accretion mass contained enough mass to capture a small piece of the solar system. However, both icy giants also have their own moons, so there is a third theory: three-body interaction. It turns out that many objects can be more than one. They are often two objects, usually because they are both the same size in a binary relationship. Instead of a large object orbiting around a small object, it's actually two smaller objects orbiting around the same orbit. The barycenter is the space between them. Binary pairs are formed when two objects of equal size are close enough to the barycenter that they prevent another larger object from separating them. However, if one binary pair is larger than the other, the chances of them being separated by the third object are greater. The orbit will be wider for the smaller one. This allows the smaller object to be captured close enough to the planet while the partner is launched into its own orbit. One strange moon seems to defy all classifications. Triton orbits Neptune retrogradely, countering Neptune's rotation. This would make it an irregular lunar object, except that it is spherical, orbits close to Earth's equator, and has a circumference almost perfect round. This is a classic description of a regular moon. It also emits mysterious icy plumes, which may indicate that it was once or maybe still is volcanically active. Voyager 2 was the first to explore the outer solar system. Before that, Neptune's moon Triton had been assumed to have been a geologically dead piece of rock approximately the same size as our moon. Voyager sent back photos that showed a world with fault lines and mountains, as well as fissures that indicate tectonic activity. Scientists were astonished by the images. The geologic forces that are usually associated with larger and warmer planets may be happening on a smaller moon than ours. Voyager detected no active volcanoes in 1989. Enceladus geysers, however, periodically erupted from Earth's surface, just like Saturn's moon. Triton's unique geological processes are amazing, but so is the fact that these are happening even through Triton's irregular moon. The majority of large moons in our solar system are regular satellites, with the exception of Triton, Neptune's largest moon, which orbits in the wrong direction. Triton, therefore, is believed to have been captured. A captured moon that behaves like a regular moon. How could an object as large as Triton be slow enough to not pass through Neptune's atmosphere or collide with the icy planet directly? While there is no guarantee, some theories have better odds. Like gamblers at roulette, Triton and Neptune trusted their luck and played the odds. There are many ways to place a bet on roulette. Each has its own odds. Like most games of chance, the better the odds are, the better the payoff. Neptune could have captured Triton in at least 3 ways. Although all 3 hypotheses can be physically proven, the first one, gas drag, is less likely. This is because Neptune only had a small amount of time to capture a proto-Triton item. This is like betting on the green zero at the roulette table. It is more likely that the proto-Triton crashed into a group of regular, middle-sized icy satellites at some point in the solar system's history. This collision was what gave rise to Triton. This is like betting on the 3rd number on the roulette table. You have a 1 in 3 chance of it happening. The best way to win is to place a bet on even numbers. You have a chance of something happening 1 in 2 times. This binary capture hypothesis is the best option for Triton capture right now. We know that there are thousands of objects in the Kuiper belt, and they would be the right size to be paired with another larger object. Neptune could then capture one of them. It is not known for certain which number was paid by Neptune to capture Triton in the early days. But Triton started to destroy everything that was in its path after it began to orbit Neptune in an unusual manner. Neptune does not have a regular system of satellites. The capture of Triton is believed to have disrupted what could have been a regular system, like other large planets. It's almost as if Triton was mad at losing his freedom and took it out upon Neptune's other hapless moons. Where did this strong-willed moon come from? Voyager 2 data shows that Triton's density is almost equal to Pluto's. This implies a kinship, unlike any other regular moon. It is believed that Pluto and Triton both originated in the Kuiper belt. These large objects were the core of the outer solar system. Some of them created giant planets, while others were thrown out further to where they now sit in the Kuiper belt. The once major thoroughfare for planetary building materials has been impacted by accretions, collisions, and even captures. The Kuiper belt contained larger objects than the average solar system history object. These objects may have had a combined mass of 50 Earth piles. However, today's Kuiper belt mass has less than 1 Earth. The Kuiper belt, which is all that remains, is as old as our solar system. The material that makes binary objects, shards from collisions, and some alien moons hasn't changed in more than 4 billion years. It is amazing to see how different the moons in the outer solar system can be. We return from the cold outskirts to our solar system feeling awestruck by the immenseness of the universe and the magnificence of the planets. It's worth stopping and taking a moment to notice the tiny worlds hidden in the shadows as we journey home. These alien moons, once thought of as an afterthought, hold secrets that human curiosity can solve.